Alright guys, welcome back to my daily Leetcode problem. Another day, another problem. This is my 9th day of doing the Leetcode daily challenge. So today's problem is quite similar to the yesterday title. So yesterday we just solved the jump game 3. If you guys have not watched, I'm gonna drop the link of my solution for jump game 3 in my description. So moving forward to the jump game 4. So yesterday was a medium problem, today is a hard. So given an array of integer, we are initially positioned at the first index. So yesterday we were positioned at the given values in here, like start 5. So we're at the index 5. So today we are at index at the position of 0. So in one step we can jump from index I to index. Alright, so let's jump to the place where we can drop a little bit more. So yesterday we are allowed to jump to the I of array plus array index and I minus array index. But today is a 3 scenario in here. So we are allowed to jump to the index plus 1, where index plus 1 is less than the array of lunch. So let's consider we are at the index of 0 in here. So we're gonna jump from 0 to the next one, which is 0 plus 1. Which is 1. So 1 is technically larger than the smaller than the array of lunch, which is 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can jump to the index of 1. The same, so but there's a different scenario for the index minus 1, because if we deduct the minus 1 from index 0, that could probably goes to the negative 1. So they have a reverse condition here. So the negative 1, the minus 1 of the index value should be larger than or equal to 0 at least, so that we could jump there. The next is if two values at the position of the array are the same, we can jump from there. So for instance, we can jump from 100 to 100, or 404 to 404, and 23 to 23. Or negative 23 to negative 23. So we have 3 cases compared to the yesterday. We have to return the minimum number of steps to reach to the last index of the array. So for yesterday problem, we have to reach to the value 0. So today we have to reach to the end of the array. So it makes sense. So moving forward to understand the problem of the example 1, they have explained like we are initially positioned at the index 0 in here. So we are at the 100. What we can do, we have a 2 position. One is plus 1. That's technically we move to the next index, which is index 1. Or we move to another index, which is 1, 2, 3, 4, index 4, because the valuation of the indexes are the same, well, 100 and 100. So we have 2 options here. So let's say we jump to the 23, we have to jump to another place, it's like maybe 23 again. Next move to the 4, 4, and then we jump to the 4, 4. So by counting that, we have jumped like 1, 2, 3, 4. So 4 steps totally. That is the one approach we could find. How about the second approach? We jump from 100 to 100, and then we jump back to the 1. Maybe we jump to the left, because we have allowed to jump to plus or minus 1 of our current index. So there or there. Let's say we jump to the 4, 4, then we already jump to the end of the index. So 1, 2, 3. So by calculation of that, we have 2 values which could reach to the end of the index of the array. That is step 3 or step 4, since they want the minimum number of the step. So we just return the 3 in here. And then let's check the constraint. So for the constraint, we are technically supposed to have minimum value of 1 in array. So that means we will never receive that empty array by all means, and the valuation could be the negative 10,000 to positive, not the 10,000, I think it's around 10 million. I'm very bad at calculating the number with the powers, so let's consider like, so that is technically 100 million. Yep, 6, 7, 8, correct. So negative 100 million to positive 100 million. So by seeing the pattern in here, that is technically the shortest path problem. We have to find the shorter paths to reach to the end of the array. So let's get started. Start writing the code. So the same approach here, we're gonna need the count of the array for sure. The reason why I need the counts in here is I don't want to count every time when I'm trying to populate the data inside the problem. So that could save up a lot of compute performance by having one variable using the count. And then we need the base case by seeing the asymmetry 2. So let's consider that if count is maybe less than or equal to 1, we just return 0 because we are positioned at the 0 and we can just simply return it. So for the next step, I was wondering what data structure we could use in here. How about we draw the graph data structure in here? What I mean by graph is we will be drawing what are the possibility of we could reach to any indice by using the hash map. So let's consider we have 100 in here. I'm gonna clean up most of the drawing. So we have 100. I want to keep track like 100 track can reach to the how many places. Like maybe let's start with the duplication of the 100. So 0, 1, 2, 3, and 4. 0 and 4. So I'm going to keep track like these first so that it will help me to populate the data in the future instead of like finding back what are the index of 100, what are the index of second 100 in the array. So let's create the graph in here, and then that could be the integer of the integer array. And then I'm going to put initially an empty at first. Yep. And then maybe just return the -1 first. What I want to do is just a one iteration approach. Let's call index 0 through the count. I want to do is there's two things we can do, like if our graph already have that data or if our graph doesn't have any data. So let's write like if let value of graph, that means like the graph of index, that means the value is already exists. What we want to do is graph of index what I mean by index should be the array of index. Yeah, that much makes sense because the index is just 0, 1, 2. So array of index, and I'm gonna append the index in here. So if not, I'm gonna assign original value like array of index will be originally index. Let's try to print that out to understand what I'm doing exactly in here. So yeah, let's check together. Oh wait, what did I do wrong here? So index of 0 through count. Oh, I'm missing the keywords ins in here. So let me check what is happening in here. Okay, I am missing the default value of subscript. Maybe if the value is already A6. Oh, okay. Makes sense. It is not array. It is the append function. Alright, another day, another problem. Just wrap it because we are pretty sure that value is exit. I think I should simplify that line of code. Alright, so we got what we want initially. So negative 23 is available in index 1 and 2, which is index 1 and 2 in here. So 100 is available in 2 places, which is 0, index 0 and index 4. So that is also keep in the dictionary. So we could get it at the O of 1. This is very ugly actually. So we could simplify by writing like graph of array of index by putting the default value, which is empty array dot append the index. So hope that could simplify our requirement. Let's check together again. Cool. So that's what I'm doing to build the graph first before trying to jump every place where we want to go. So this is going to be the North Star for us throughout the problem. And same as yesterday, we could probably need the visited array, which is just keep track of the Boolean value, like the index 0, we have already go there, or index 1, did we already go there or not? Let's call false and count by be count. So moving forward, we will just put the visited of 0 as true because we initially positioned at the index 0 in here according to the description, like we are positioned at that first index of the array initially. So I'm gonna put index of 0 as a true. Let's start with our real problem here. Let's count like I need a base case in here. Let's go Q because we want to keep track of how many Q we have done so far, like the problem from yesterday. So initially we have a Q put at the 0, so the Q is like keep track of index. And we're gonna need the one more condition here just to keep our iteration keep going until the end of the array. So let's use the Q as our debreaker. So we're gonna check if Q is empty. If not, so that will be the reverse because Q is originally is not empty anymore because we put the initial of the 0. And what I want to do is let's calculate the size of the Q, which will be the Q.count. The reason why I want to keep track of the Q count is what if our Q is totally empty initially, or we accidentally remove all the Q, and then what is the next step? What we need to do? We could simply break that loop. So what I want to do is let's call it like for in 0 truth the end of the Q. What I want to do is let's pop up the Q ident by using the React Q data structure, which is remove first. So we got first value of Q in here. So first value of Q is technically 0 at this time. So what we can do is we can start calculation of the step. Let's consider one more variable called like step. So what I mean by step is that is going to be the actual answer that we want to return. Originally is at the 0, and then what I want to do is if our index if exactly equal to the count minus 1. I was wondering, should I do the count or not. So if count -1, that means we are at the end of the array, right? Because let's say the count is 10, so count -1 is 9, index is 9, so we return the step. That's our goal. So we have got the condition to break it, these, and then we need to approach. So we need to consider of these three conditions here. If our index, index +1 is less than count, which is given here, we are eligible to do the, okay, instead of using the two variable in here, how about we call next index? Sorry for the so many complication of variable. That is what I can think at the moment right now. So originally empty. What I want to do is next dot append our index +1. The same for the next step. Index -1 is greater than or equal to the count. We will append the -1. Right, cool. That we still need the one less than. So the less than will be if our two valuation are same. Yeah. Alright, let's check if let maybe x first. I don't know how to name that first. What I want is I want the value of these indices graph of the next step. So we have graph already existing, and then I want to check is if array of index, let's go same value index. So what I mean by same value index is that could be the reverse or originally here. So what I am doing here is I am trying to check the index. Let's go 4 in here. We are at the case of index of 3, and then I've got the 4. But I want to get the value of index available for the 4, which is 3 and 9. So if I got 3 and 9, what I will do is I'm gonna append to the next index. So why I am doing that is I can explain in detail. So if I keep track of all the Q and index, I could update it for the next index. And as we remember, we have one more variable to not to make a time limit AZ in here, which is next in, let's call visited. Let's go next index. But we need to check if do we already visited that index or not. So if visited is true, we don't need to do anything. If false, we need to do something. What we need to do is we will mark that index as true, and we're going to add that to the queue, which is the queue is in here, and I'm gonna append to the next. Yep, I think that is pretty much, and after this a while I can update my steps to the +1. Yep, let's try to run locally first before we submit. Oops, I did not typo again. Exactly, visited. Oh, this is so wrong. Should be visited. What is the problem here? Next. Oh, my bad. I'm so bad at writing on the plain text editor because I'm iOS engineer, of course. What did I do wrong in here? A pen. Oh, we expecting the content of. And that and run. Ooh, what did I do wrong? Let's check. I think there is only one place is seriously wrong that could help us solve most of the problem. Let me check. Did we calculate the count properly? Yes. And did we check the evaluation properly? And yes. Alright, let's go through the problem one by one. Array of false originally is, that's also true. And step originally is true. We have a size q. I'm removing the first in here for the index. I still check count -1. So that is for the answer we are doing right. And for the next index C, we are checking like index +1 is less than to the count, which is true. And I append the index +1. And next index will be the appending the index -1. Everything looks good for me. And then, oops, I think there's something missing here. Maybe I probably want to clean up after we have been through for the graph. Array of index. Why do I need to clean that? I think if we have visited the graph, we could simply remove that with nil. So that will help us get rid of the existing visitor place that we have gone so far. So let's check together. Interesting. Because of print, output is 4. What could cause the output to 4? I then need to debug more detail. This is good. This is also good. Wait, let me try again. I have no idea of what's happening at the moment right now. Okay. Now we need to debug on the live recording. Sorry about that. Okay, originally we have a count. That's totally good with that. And we have a graph. And then from graph, we go through the 0 to the count. That we create the graph properly. Yes. And we only append the index. That's also true. Next is, alright, what could be the problem? We are returning the +1 one more time. So maybe we print the visited in here. I just only worry one thing. I am doing wrong for the queue, but that's not true because we are in the list. Alright, let's check my assumption first. So everything is the same. So we go the 4 places. So originally is everything is false. And we have, why do we want to the index 1 at all? Well, that's a serious problem to solve. really interesting. Zero true count. Graph of, we go through all the indices. The graph part is correct. So this is, let's print the graph also if we need. And we got Q in here. So let's get back to the Q is empty. Maybe it should not be, but let's try. I have a doubt of this variation because every time we set up back the visited as a 0, right? Cool. We got what we have for the problem in here. We got step origin as 0 and Q count. It's getting more interesting first. So after we done through the same indice, we stay upon our same value indice. Then we just check through the graph is empty or not. Why is that next so weird? The Q is also true. Visited also true. Right, let's try again locally. Wait, did I solve the wrong problem? No. This is getting serious. Okay, let's debug line by line. Okay, let's check the graph first before we do anything wrong. So the graph is correct. Yeah, let's check 1, 2, 3, 4. Let me calculate how many graphs are we missing. One graph. So it's supposed to be 5 according to here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's true. So after done with the graph, we will check the visited. Visited. Let's run. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's also true. So we also check the Q. There must be something wrong just one place. I cannot think of it. Oh, I forgot to put something else in here. Remove words. That's also true. Index, but that should not be because it's a separate index. Okay, never mind. Let's continue debugging. I'm pretty sure the problem is in here. So index plus 1 is less than the count. We will append the index plus 1. If index minus 1 is greater than or equal to, holy crap, that is 0. Oh my god. I probably hit the time limit AC problem because I have a lot of print in here. Let's clean up. Alright, I don't know how come I write the cow instead of 0. No, that's crazy. Anyways, that's a good example of we should not be careless during that interview. It will be panic modes. Alright, let's check the runtime complexity is at O of n since we don't use any extra or any nested in here. How about the memory? Same O, we just use the one visited array as a data structure, the same for the queue. So that's O of n. Yep, that's pretty much for it. And then hope you guys enjoy my debugging and sweating. See you in the next one. Bye.